Okay, here we're going to look at a couple more rules. One, that if you have a constant times a function and you're taking the derivative, you can pull the constant out and just worry about taking the derivative of the function and then multiplying it by the constant afterwards. In particular, if you have a times x to the n, you can just bring the n out front and lower it 1, and there you have it. It's n times a times x to the n minus 1. Okay, also, if you have a sum, you can split it up and worry about the derivative of that plus the derivative of that. You don't have to handle the whole thing at once. So this allows us, these rules really allow us to handle really any kind of sum that resembles a polynomial. It doesn't even have to be a polynomial exactly, but various kinds of sums. Here's a simple one, 3x to the 3 times x to the 4th power. All I have to do is bring 4 out front times 3x, lower it 1 to 3, right? And that's 12x to the 3rd power. Well, that was easy, right? Here's another one, but this one's a sum. But I can work on these individually. Also, I'm going to bring this up so it's x to the negative 1. And I'm going to write it like this. I'm going to write it as 1/3 times x squared, okay, minus 5 times x to the negative 1. But I'm going to write prime here because that's what a lot of students don't do. They might write this out. Now I've just got a number times x to a power plus a number times x to a power. Okay, so this is going to be very easy. I do this one and I do this one. I bring the 2 out front. I don't know if you can get down here low enough. 2/3 x and to subtract 1 from 2. And then minus, I bring the negative out front. That becomes plus, doesn't it? 5x to the negative 2. And I've taken the derivative, so I don't have a prime on there, do I? And I should. And I can write this as 2/3 x plus 5 over x squared as a positive exponent. This is a perfectly good answer. This is a better one if you're going to evaluate. Okay. Now here's one that all my students miss. They don't see what's going on here. You know, what this really is what? It is, I can split this up. This is 1/6 times x plus pi. Okay? First of all, the derivative of pi is just a number. It's a constant, so it's a horizontal line with y equals 3.14, so its slope is 0. This is just a line with a slope of 1/6, so my answer is 1/6 plus 0, or just 1/6. I had some students staring at that, couldn't figure that one out for the life of them. They didn't see. When you have x over the 6, remember it means 1/6 x. That's the idea. Now here's a nice one, and it's got an evaluation symbol here. I have to evaluate it. The first thing I'm going to do, though, yes, I forgot my prime. Yes, we good? Okay, I've got, see, I almost made the mistake. I'm taking the derivative and I'm evaluating it at 1. The first thing I'm going to do is rewrite it. I've got 4x cubed, that's an easy one, minus 2x to the 1/2 plus 5/3 times x to the negative 1/2, and we're going to evaluate this at x equals 1. I put it in this form, so I'll have a number times x to the n. Number times x to the n, number times x to the n. Yeah, prime. Oh, thank you. I haven't taken the prime. See, my student there reminded me, left off the prime, because that wouldn't be equal to this, would it? If I wrote equals, it wouldn't be equal to that. Okay. So I've got this, I've got it exactly the way I want it, and I just bring the 3 out front, lower 1, bring the 1/2 out front, lower it by 1, bring the negative 1/2 out, lower it by 1, and I get 12x squared. Minus 1/2 of 2 is 1, minus x. Negative is going to give me half, it's going to give me negative 5/6. Is that right? Negative 5/6, yeah. Times x to the what? We're going to subtract 2 halves, or 1, and then it goes negative 3 halves, right? And we're going to evaluate this, and now I don't have to have a prime anymore because I've taken the derivative at x equals 1. So I have to plug 1 in. It's kind of awkward to plug 1 in on a negative exponent, so I'm going to have to bring that downstairs. But 12 times 1 squared minus 1. Notice I'm using parentheses. The best plug-in method is always to put a set of parentheses in place of x, and then put your plug-in number there. And this is going to be negative 5/6 over this to the 1 to the 3/2 power, right? I didn't really have to do that. And so I plugged in 1 everywhere. Of course, this is, if you 1 squared and 1, and it's going to give me 1 each time, so it'll be 12 minus 1 minus 5 over 6. And I assume you can add that. I don't have enough room to do it. I'd probably I'd probably take 11 to 66. 6 minus 5 is 61.6, I believe. Is that right? 61.6, is that one? It is, because this is 11, yeah. Okay. So there it is. All right.